if you observe the metric system, when you're talking about length, all the unit of length in the metric system has a word meter, okay? Because meter is the base unit of length. And if you want to express them as a smaller or a bigger unit, you just use prefixes. So that's the purpose of having prefixes in your metric system. So the following, these are just common prefixes that you use. So femto means 10 to the negative 15. Pico means 10 to the negative 12. That means that if I'm talking a very small amount, it could be amount of time or, well, the mass of an object. So usually I use these smaller prefixes on the left-hand side. The right-hand side is used to represent bigger quantities. So again, this one here is to represent bigger quantities. And then the other side is for smaller values. Okay? Because when you say, let's say, what is the meaning of one? Say 1 microgram. So if you have that one there, if you use this one here, 1 microgram means that you have 1 times 10 to the power of negative 6. So if you can observe, micro, the significance of micro is that you have 10 to the power of negative 6. So 1 microgram is a small quantity because 1 to the negative 6, that is a very small, you have 0.00 something. So if you can remember about your scientific notation, this is equivalently to 0.000001 gram. Okay, so 0.00001 gram. Okay, so if I talking about, let's say, bigger distances or what, I can use mega or giga. So let's say if I'm talking about 1 gigameter, so 1 gigameter, well, that is just equivalent to 1 times 10 to the power of 9 meter. So if you can observe, I'm just using a prefix to represent a very large value. That's 10 to the power of 9. Giga is to the power of 9. Or if you're going to write that one into the standard form of the number, that is 1,000,000,000,000 meter. Okay, so that's around what, 1 trillion, or no, 1 billion, or 369. Yeah, 1 billion. Okay, so let's answer this one up together. So the distance between Vancouver to Madrid is approximately 8,400 kilometers. How many meters is this? So we want to express our unit from kilometer to meter. Okay, so we want 8,400 kilometer to meter. Okay, so using the prefixes there, is it not that kilo means to the power of 3? Okay, that's to the power of 3. So therefore, I can just write that one down as 8,400. And then if I'm going to replace my kilo, I'm just going to replace it with the multiplier. And the multiplier of kilo is 10 to the power of 3. So kilo means 10 to the power of 3. So I'll just replace that one with times 10 to the power of 3. And when I do that, I can take off the kilo, and that becomes meter. But this is not your final answer because this is not in standard scientific notation form. Okay, so if you can remember, how do we write a standard scientific notation? Is it not that the standard form of a scientific notation is m times 10 to the power of n? Okay, so this is the standard form of a scientific notation. You have this whole thing. Well, we define m. The value of m is, remember that m has a specific value. M is greater than 1. So M should be greater than 1. No, greater than or equal to 1. Okay, greater than or equal to 1, but less than 10. Okay, so make sure that M is must be greater than or equal to 1. So the smallest would be 1, but it doesn't exceed 10 or cannot have a value of 10. Remember that this is less than 10. So the value of M should be in between 1 or anything that is less than 10. So 9.99999. And N is just the exponent. So N is just the exponent, which tells you the number of decimal places that you move. Okay, so therefore to answer this one here, okay, so if I'm gonna express 8,400 times 10 to the power of 3 into its normal form or standard form, remember that times 10 to the power of 3 tells me that I'm moving my decimal place 3 places to the right. So therefore 8,400 times 10 to the power of 3 again is the same thing as 8400. In this case, my decimal point is here after the 0. I'll be moving that one 3 places to the right because it's positive. 1, 2, 3. So I'm gonna add the empty spaces with 0. So therefore, in standard form, this is equivalent to 840,000 meters. So this is the standard form. So standard form of the number itself. But if you're gonna express this one as a scientific notation, it would be equivalent to 8.4. Remember that M should not be greater than 10. It should be no, it should be less than 10, but it should be greater than 1. So you choose 8.4. Okay, 8.4. Now, for the exponent part times 10, what would be the value of your N? Well, the value of your N is, in this case, you're starting with a big number. So your decimal place is here. So if you're going to move to the left, you try to count the number of places that you move, your decimal places. So that's 1, 2, 3, 4, 5, 6. So that's to the power of 6. And it's positive because you're moving to the left. Or just think this way. If you are dealing with a large number and then you're going to express it in the standard scientific form or scientific notation form, make sure that you check the exponent. The exponent should be positive in the particular case. So this one here is around 8,400,000. So 8 million is a big number. So I can expect that the exponent is positive. Okay.